Hi viewers, I'm going to be showing you some of the bottlenecks that I discovered during the EZKL pipeline. Let's get to it. So first things first, I just want to set up my environment, install all my necessary packages, and make sure that everything is running correctly and right. Okay, so here we have two API models. One is sequential and one is functional. So the very first problem was a key error that was talking about Keras TensorFlow. So this is basically just a name error where, which is basically the cause of the sequential API model not having the attribute output names. Because if you look deeply into the module documentaries, you will realize that there is going to be a dictionary that is going to be called tensors to rename, which is basically just going to map all the Keras structured names to the TensorFlow names. And then there's going to be another dictionary that's going to be called reverse lookup. This basically just switches the positions between key and value. So where key is, the value will be. Where the value is, the key will be. That's how reverse lookup is. And then it will trace that tensor. But because sequential APIs don't have that method, it's led us to this problem. So that was why the best solution was to use functional API models, because that is the model that actually has the attributes output names. As you can see, we have our inputs, then we flatten it, then turn it into a dense layer. Now we have our second problem, Reshape to ToTypedTranslator. Why flatten is the problem? So basically, it was more of a structural problem. Instead of making inputs in nested structure, we had to make it flat. So that was the main problem. As you can see, it fails at nested 128 layout. So we have to flatten it and make it only 2D and not, I'll make it only 1D, not 2D. So using reshape at -1 was the exact function that was going to solve this problem to help us continue with the deserialization process. Reshape at -1 basically just turns a 2D vector or any other dimensional vector into a 1D column vector. And here we have our inputs, which has been properly serialized. Okay, so basically proof just needed explicit arguments. in the documentation, it wasn't explicitly stated. So after asking my AI agent a few questions, it explicitly told me this. Then the pipeline is also very slow. So it's very advisable that once you run your EZKL pipeline once, try not to run it again. So the better idea is to put the entire pipeline into a separate file, then continue with whatever you're doing in another file. Okay, so this is how the pipeline works. We have an input tensor that is about 28 by 28 pixels. Each cell has only one float or digit. Then we use a conv2d tensor layer, which basically creates 32 feature maps, each by 26 by 26 as the dimensions. After that, we flatten or reshape them, turning the entire layer into a 1D vector style layer, which is why the dimension is going to be 26 by 26 by 32, which equals to 21,632 values. So more than 21,000 values are stored inside one column vector, as in the name flattened. Then we turn that into a dense layer where it produces 10 unique scores, which all sum up to 1. Thank you for watching, and I'll see you in the next video. You can also check out the full documentation on my GitHub, as I'll be putting it in my description. Thank you.